When we think of fossils, we usually picture hard things. We imagine bones, teeth, and shells. These are the durable parts of an organism, the bits and pieces most likely to survive the immense pressure and unfathomable spans of time required to become mineralized relics of the past. Soft tissues, on the other hand, are the first to go. Brains, muscles, and guts are delicate, squishy, and incredibly prone to decay. They are usually devoured by scavengers or decomposed by bacteria within hours or days of death. Finding a fossilized skeleton is a triumph of geology and luck. But finding a fossil with its soft tissues intact, especially a brain, is like finding a ghost beautifully preserved in stone, an event so improbable it borders on the miraculous. This rarity is precisely what makes such discoveries profoundly important. The fossil record is our primary window into the history of life on Earth, but it's a window with many missing panes. Without soft tissues, we are left to guess how ancient creatures moved, how they processed information, and how their internal systems functioned. We can infer muscle attachments from bone scars and guess at organ placement from body cavities, but these are educated estimates. A fossilized brain, however, is not an estimate. It is direct, tangible evidence of a nervous system that existed over 500 million years ago, offering a concrete snapshot of a creature's complexity when all we previously had was a fuzzy outline. Imagine trying to understand how a car works by only looking at its metal frame. You could see its shape and size, but you would know nothing of the engine, the wiring, or the seats. That is the challenge paleontologists often face. The discovery of preserved soft parts is like suddenly finding the engine and the full wiring diagram. It transforms our understanding from a simple sketch into a detailed blueprint. It allows scientists to ask more complex questions about an animal's behavior, its sensory capabilities, and its place within the grand, sprawling tree of life. Each such find is a Rosetta Stone for deciphering the biology of the deep past. The conditions required for such preservation are extraordinarily specific and exceedingly rare. The organism must be buried rapidly in fine-grained sediment in an environment with very low oxygen levels. This combination seals the body off from scavengers and slows down the process of bacterial decay, creating a tiny protected tomb. Over millions of years, as the surrounding sediment turns to rock, the delicate organic matter can be replaced by stable minerals like pyrite or carbon films, creating a perfect three-dimensional impression. It's a geological lottery, and the winning tickets are some of the most scientifically valuable fossils ever unearthed, providing us with an unparalleled glimpse into the inner world of ancient life. Let me introduce you to the star of our story, Fuxianhuia protensa. This creature is not a dinosaur, it's not even a vertebrate. It lived and died long before the first fish swam in the oceans during a period of explosive evolutionary innovation known as the Cambrian explosion, roughly 520 million years ago. Fuxianhuia was an early arthropod, a distant relative of today's insects, spiders, and crustaceans. It had a segmented body, sturdy legs for walking along the seafloor, and a simple head shield. It was a humble pioneer, one of nature's early experiments in building a complex, mobile animal. It scuttled across the muddy bottom of ancient seas in what is now modern-day China. The fossils of Fuxianhuia were discovered in a world-famous fossil site called the Xinjiang Biota in Yunnan province, China. This location is a type of fossil deposit known as a Lagerstätte, a German term for a storage plate. These sites are paleontological treasure troves because they preserve life with exceptional quality, including the elusive soft tissues. The fine mudstone of the Xinjiang deposit was created by ancient underwater mudslides that rapidly buried entire communities of marine animals. This instant entombment is the key to their stunning preservation, creating a perfect snapshot of an ecosystem frozen in time for over 500 million years, capturing the delicate details that are almost always lost. For years, paleontologists have studied the many Fuxianhuia specimens pulled from the Xinjiang rocks. They are relatively common fossils at the site, giving us a good idea of their external anatomy. We knew about their exoskeletons, their jointed limbs, and their general body plan. But what was going on inside remained a mystery. It was assumed that the internal organs, particularly something as fragile as a brain, would have turned to mush long before fossilization could ever begin. The search for the inner workings of these ancient arthropods seemed like a hopeless quest, a detail lost forever to the ravages of time and decay. But then, a team of researchers, including Nicholas Strausfeld from the University of Arizona, looked closer. Using advanced imaging techniques on a particularly well-preserved specimen, they saw something astonishing. There, nestled within the head shield of this 520-million-year-old creature was a clear, unmistakable outline. It was the fossilized remains of its brain and central nervous system. This wasn't just an impression, it was a carbon film that had replaced the original neural tissue, preserving its shape with incredible fidelity. Suddenly, we weren't just looking at the shell of Fuxianhuia, we were looking into its mind. What does a 520-million-year-old brain even look like? Remarkably, it looks both simple and familiar. The brain of Fuxianhuia is divided into three distinct parts. A tripartite structure that directly corresponds to the brains of modern arthropods like insects and crustaceans. There is a forebrain, a midbrain, and a hindbrain, each connected to different sensory organs. This discovery was a bombshell because it pushed back the origin of this complex brain structure by tens of millions of years. It suggests that the fundamental blueprint for an advanced arthropod brain was already in place very early in the history of animal life, much earlier than anyone had previously dared to suggest. The level of detail was stunning. Scientists could trace the optic nerves extending from the brain to the creature's stalked eyes. They could also identify nerve cords running from the brain down the length of the animal's body. This intricate preservation told them that Fuxianhuia had a centralized nervous system, capable of processing visual information and coordinating the movement of its many legs. This wasn't a simple worm with a diffuse nerve net. This was a sophisticated animal with a command center, a creature that could navigate its environment, find food, and avoid predators with a level of complexity we had only guessed at before. This finding helped settle a long-standing debate in evolutionary biology. Scientists had wondered whether complex brains evolved multiple times independently or if they evolved once in a common ancestor. The brain of Fuxianhuia provides powerful evidence for a single early origin. Its structure is so similar to that of modern malacostracans, a group including crabs and shrimp, that it suggests a direct evolutionary link. As Nicholas Strausfeld put it, the fossil provides a fossilized missing link that connects the anatomy of ancient and modern arthropods, showing that this successful brain design is an ancient and enduring one. The discovery fundamentally changed our picture of the Cambrian explosion. This period was not just an explosion of external body plans and new shells. It was also a time of incredible neurological innovation happening on the inside. The fierce evolutionary pressures of the Cambrian, the rise of predators, and the need to compete for resources were driving the evolution of complex brains and sensory systems right from the start. Fuxianhuia shows us that the cognitive toolkit needed to be a successful arthropod was forged in the crucible of this ancient evolutionary arms race, establishing a pattern that has persisted for more than 500 million years. The discovery of Fuxianhuia's brain is a powerful reminder that the fossil record still holds immense secrets, waiting for the right combination of luck, technology, and curiosity to unlock them. For every question that a fossil like this answers, it opens up a dozen new ones. If a brain can be preserved, what else might be hiding in these ancient rocks? Could we find fossilized hearts, digestive tracts, or even reproductive organs? Each new discovery of soft tissue pushes the boundaries of what we thought was possible and adds another layer of richness to our understanding of the past, transforming shadowy figures into fully realized organisms. This is the true excitement of paleontology. It is not a field that is finished or complete. It is a dynamic and ongoing investigation. New fossil sites are being discovered, and new technologies allow us to re-examine old specimens and see them in entirely new ways. Techniques like CT scanning, synchrotron imaging, and chemical analysis can reveal microscopic and molecular details that were invisible to previous generations of scientists. A fossil that has been sitting in a museum drawer for a century might suddenly yield groundbreaking data when viewed through a new technological lens, proving that the next great discovery might already be waiting on a shelf. The scientists who make these discoveries often express a profound sense of awe and connection to the deep past. Nicholas Strausfeld described the moment of identifying the brain as a jaw-dropping aha moment, a sudden electrifying recognition of a familiar structure in an impossibly ancient context. It's a feeling of bridging an unimaginable gulf of time, of seeing a direct link between a creature that lived in a long-vanished world and the life that surrounds us today. It's a testament to the enduring power of evolution and the incredible, improbable journey that life on our planet has taken. Ultimately, every fossil is a story. It tells a tale of life and death, of survival and extinction, of a world that was both alien and strangely familiar. The fossilized brain of Fuxianhuia pratense is one of the most incredible stories yet uncovered. It speaks of the ancient origins of thought and perception, and it challenges us to keep looking, to keep digging, and to keep wondering. The history of life is written in stone, and we have only just begun to learn how to read its most intricate and fascinating chapters. What other ghosts are waiting in the rocks for us to find?